This video is about solving a system of equations using the substitution method. So substitution is another way to solve linear equation. It involves no graphing, but we still need to write our answer as a coordinate pair because it represents the intersection point of two lines. So when we are solving with substitution, we need one of our equations to have a variable by itself. So in number one, we have 2x plus 3y equals 13. And y equals 6x minus 9. So we want to take what y is equal to and replace y in the other equation so that we can get rid of one of the variables so that we can solve. So when we substitute, we rewrite everything the same. When we get to the variable we're replacing, though, we put parentheses with our new part of the equation. So 6x minus 9 equals 13. Now we know we substitute correctly when there's only one type of variable in the equation. So in this case, we only have x's. So now we can solve for x. So we would distribute the 3. 2x plus 18x minus 27 is equal to 13. We can combine the x's. 20x minus 27 equals 13. We can add 27 to both sides. 20x equals 40. So we divide by 20, x equals 2. Now, we're not done with this problem yet because we need to know the value of the other variable. So we are going to take this 2, and we can substitute either in the first or second equation. So because y is by itself, I'm going to substitute the second equation and make my work a little easier. So y equals 6 times 2 minus 9. 6 times 2 is 12. 12 minus 9 will get us 3. So our point is 2. In number 2, we have x equals 7 plus 3y, and we have 3x plus 7y equals 3. So in this case, the x is by itself, so we're going to box what x is equal to, and we're going to substitute in for x in the other equation. So everything else stays the same. So we have 3 parentheses 7 plus 3y plus 9y equals 3. We did this correctly because we're only left with y's. So to solve for y, we would distribute 21 plus 9y plus 9y equals 3. We can combine the y's. 21 plus 18y equals 3. Subtract 21, 18y equals negative 18. When we divide by 18, y equals negative 1. Again, we're not done yet, though, because we need our x value. So we're going to take negative 1 for y. We can put it into either equation. This time I'll pick the first equation because x is by itself, so it makes the work a little easier. So x equals 7 plus 3 times negative 1. 7 minus 3, so x equals 4. So our ordered pair would be 4, negative 1. So when we are solving a linear equation, we first need to find the best variable to solve for. The best variable to solve for is a variable that has a coefficient of 1. Then we substitute the expression into the other equation and solve for our variable. We substitute the number into one of the equations and we solve for the other variable. So in 3, 4, 5, and 6, we're not going to solve yet. We're just going to identify which variable would be the best to solve for. So we are looking for the variable that has a coefficient of positive 1 in front of it. So in number 3, that would be x. In number 4, that would be n. In number 5, it would be x or y in this case, because they both have a coefficient of 1. And in 6, it would be c. So just like we did before with solving for a variable, we need to do the one extra step first. We need to get a variable by itself. So number 7, we have 2x plus 2y equals 3. And x minus 4y equals negative 1. So the variable that we want to solve for here is the x because it has a coefficient of 1. So in order to solve for x, we need to move the 4y away. So we're going to add 4y to both sides. So we get x equals 4y minus 1. Now that we have x equals, we're going to take what x equals, and we have to be really careful about where we substitute here. because we don't want to substitute into the second equation, as that's the equation we worked with. We just rearranged it. So we want to substitute for x in the first equation then, because we haven't done anything to that yet. When we rewrite this, we have 2 times 4y minus 1 plus 2y equals 3. So to solve for y, we would distribute 8y minus 2 plus 2y equals 3. We combine our y's. 10y minus 2 equals 3. We can add 2 to both sides. 10y equals 5. We divide by 10. We get y equals 1/2. Then we're going to take our y value and we're going to substitute in to find x. So we can pick either equation. This time I'll pick the first one. We have 2x plus 2 times 1/2 equals 3. So we get 2x, half of 2 is 1, so 2x plus 1 equals 3. We can subtract 1 from both sides. 2x equals 2, divide by 2, x equals 1. So we have 1 and 1/2. In number 8, we have 3x plus y equals 5 and 4x minus 2y equals 20. So this time, this y in the first equation has a positive coefficient of 1. So we want to get that y by itself. So we need to move positive 3x to the other side. So we're going to subtract 3x from both sides. This turns into y equals negative 3x plus 5. So now we are going to box what y equals, and we're going to put it in for y in the other equation, which is the second equation because we haven't manipulated that at all. So we have 4x minus 2 times negative 3x plus 5 equals 20, and we can solve for x. So we're going to distribute. Remember that 2 negatives equal a positive. So 4x plus 6x minus 10 equals 20. We can combine the x's. 10x minus 10 equals 20. Add 10 to both sides. 10x equals 30. Divide by 10. So x is 3. Once we know x is 3, we're going to substitute back into either equation. So this time I'll use the second equation. We have 4 times 3 minus 2y equals 20. So we get 12 minus 2y equals 20. We can subtract 12 from both sides. Negative 2y equals negative 8. Divide by negative 2. So y is 4. So we get the coordinate 3, 4. In number 9, we want to get a variable by itself. So we're going to get this x in the second equation by itself. So we can subtract 3y from both sides. We get x equals negative 3y. So we can substitute negative 3y in for x in the first equation. So we have negative 2 times negative 3y minus y equals 0. That gets us 6y minus y equals 0. 5y equals 0. And we divide by 5, y equals 0. Then we can substitute to get x. So I'm going to take 0. I'm going to put it in the second equation. So x plus 3 times 0 equals 0. X plus 0 equals 0. So x is just 0. So our ordered pair here would be 0, 0. In number 10, they already gave us the y value is negative 7. So we already know y equals 7. So this makes our problem a little bit easier because we just need to find x in this case. So we have 4x plus 3 times negative 7 equals 13. 4x minus 21 equals 13. We can add 21 to both sides. So we get 4x equals 34. When we solve, we get x is 17 over 2 when we reduce our fraction because we divide by 4. So we get 17 over 2 for x. So we would have 17 over 2, comma, negative 7. In number 11, we already have the y by itself, so it saves us one step. We can just substitute in for y in the second equation. 3x minus x plus 3 equals 1. We're going to distribute this negative 1, so we get 3x minus 3 equals 1. We can combine the x's. 2x minus 3 equals 1. Add 3 to both sides. 2x equals 4. We divide by 2. X equals 2. Once we know x is 2, we can take that value and substitute in. So we'll use the first equation. Y equals 2 plus 3. So we get y is 5. So our ordered pair is 2, 5. In number 12, we don't have a variable by itself. We have a positive x. So we can add y to both sides in the first equation. X equals y plus 4. So we can take what x is equal to and we can substitute in. We have 4 times y plus 4 plus 4y equals 16. We can distribute the 4y plus 16 plus 4y equals 16. We can combine our y's. 8y plus 16 equals 16. We subtract 16 from both sides. 8y equals 0. Divide by 8. So y is 0. Once we know y is 0, we can substitute back in. So x minus 0 equals 4, which just gives us x is 4. So we 4, 0. In number 13, the sum of a large and small number is 93. The large number is 9 less than 5 times the small number. What are the two numbers? So our variables here are going to be L for the large number and S for the small number. We know that the sum of the large and small number is 93. So sum is addition. L plus S equals 93. Then we have the large number is 9 less than 5 times the small number. So L equals 5S minus 9. Now, if we look at these equations, we see that we already have L equals. So we can box what L equals, and we can substitute in for L. So we have 5S minus 9 plus S equals 93. So we get 5S minus 9 plus S equals 93. We can combine the S's. 6x minus 9 equals 93. Add 9 to both sides, so we get 6S equals 102. When we divide by 6, S is 17. Then we can take 17 and we can substitute. So we have L plus 17 equals 93. We can subtract 17 from both sides, so L is 76. So we get the ordered pair 76, comma 17. So the large number is 76 and small number is 17.